for joining us this afternoon. Pizza and a wonderful, wonderful presentation, but more importantly, an amazing woman. And I get the pleasure of introducing her to you. It starts by knowing that she has won the Ball State University Alumni Award of Excellence. So for that, we can give her a round of applause. And that is what brings her here today. And it's in celebration during homecoming week. So if you're at the game on Saturday, you'll see Kat will be called out there and another kind of award bestowed upon her. And she will go into the field and receive that. So very, very exciting. So Kat Klingenberg is truly a visionary. And over the past 25 years, she's driven the adoption and development of passive building and zero energy standards. Now, passive building originated in the United States and Canada in the 70s, and it was really pushed forward in Germany, which is where Kat is from, in the 90s. And that's important just as a general timeline, because Kat came to Ball State University for her Master's of Architecture, probably because of our renowned, understanding of sustainability and pushing for energy standards. And I know it was at the forefront. I started teaching here in '93, and it was one of the driving forces of myself coming here to teach. So she graduated with the MArch in 1996. Wonderful. She then went on to really invigorate, or reinvigorate, I should say, because the United States had passive house standards, but she basically reinvigorated it with much of the understanding of what was happening in Germany, her home place. And in 2003, she completed the first home to meet passive house standards in the United States. Now, this is important also because you all know the Alley House has achieved significant accomplishments, right? Notably the winning of the decathlon, solar decathlon build. But in terms of pride that I carry forward, this is the achievement. We have just recently been passive house certified. So this is terrific. Awesome. And interestingly enough, this arrived in the mail yesterday. So what she did is basically founded a nonprofit organization called Phius, which stands for Phi US. Phi is Passive House Institute. The US makes us refer to it as Phius. And basically, when she built her own home, as you can imagine, to the standards, it sparked a lot of interest. And it was in Illinois, in Urbana-Champaign area. And people were asking how to do this, or what are you doing, or what are the things that you're trying to promote? And it was at that time that she founded the nonprofit organization Phius. Now, you know a little bit about it. It's dedicated for best building practices. What you also don't know is what an incredible force Katrin Klingenberg is in Phius. Amazing. She's everywhere. Everyone absolutely knows her, speaks so highly of her, and she just yesterday came from the Phius conference in Provincetown, and it was amazing. Always well received. Last year, we went to the one in Houston. It's just an incredible accomplishment. So not only does she run with her group of amazing individuals too that are working it, but all the standards and the certification, and goes through the design certification and then the built certification. It's one thing to say you're going to do this, but you also have to show that you do this by actually accomplishing all the incredibly difficult standards that make this the best performing building. So Phius has now updated, so she's been continually in there since 2003, 2004. It's now 2024. And it's really interesting, I think, because the shift a little bit, still keeping, of course, the most stringent efficiency goals that you can have, but they've also added carbon neutrality to the equation. Really important, as we all know, right? So So the building block of the 21st century is to look at resilient, digitized, distributed, and interactive environments. Now, on top of leading the Phius in the United States in Chicago, she's of course incredibly accomplished, written many articles and book contributions. And some of the most recent ones are Stranded Carbon on the Approach Every Project as though Phius Plus, the building of the natural code of the future, were in effect. So again, the emphasis on carbon neutrality on top of energy efficiency has really become something important. A couple other things, there are a lot of accolades. Actually, Ball State awarded the Alumni Award to her, but CAP also gave her the award for the alumni, so outstanding alumni. So she's received a number of awards from her post-university here. But in 2015, she won the Women in Sustainability Leadership Award. And so she was one of 12 women entrepreneurs that was selected for this global program of Vital Voices in 2017. And she's also a senior fellow of the National Building Institute and has won a number of other awards related directly to what she does. But I think it's really significant too. Andrea and I were talking about this. I think Andrea started in 92 here, I in 93, and it was a little challenging of an environment for women to teach in, to practice in, but to head an organization like Passive House and get everyone on board to really look at energy and now carbon neutrality standards, it's incredibly commendable. So I am so honored and pleased to introduce Katrin Klingenberg to you all.
So, can you hear me okay? Am I mic'd up okay? No cross-feeding, all good. Perfect. I just got off the highway. And 4 hours of driving from Chicago to Muncie. I had a few images kind of roll off in my inner video stream. And so it really feels like as if this was just yesterday. I know I probably don't look like a spring chicken to you all anymore, but it does feel really like not that much time has passed. So time is really interesting that way. And I'm really glad to be back. I'm honored to receive the now university-wide award. And thanks, Pam, for the great introduction. I believe one of the motivator for this award was also highlighting women leadership and entrepreneurship in the environmental field of our profession. So funny, this year I am also going back to school. So this is kind of like a little bit an event that sparked some more thoughts of coming back to Ball State and what you guys might all be thinking and what the place might be that you are all in. So I'm very happy, to see a lot of women in the audience. So that was not the case when I was here. So we definitely have made some progress in that regard. But I also was musing about like my thesis team. Pam was one of them, and there was John McCrory, and there was Sunny Palmer. Some of us have already left, so Sunny passed away, I think, like 15 years ago already, or 10. Again, time is funny, right? But I'm greatly indebted to this incredible team to break me out of the box. And I don't know if this is still the case, how people teach, but now that I'm going back to school, the University of Chicago has a program that is aimed at leadership in society. So it's for people like me who have accomplished something, but think they might be able to do a little bit more with like social impact. And during that class, they were trying to teach us to break us out of the box that most of us have been in. Most of us have been like CEOs, and we were very like focused single-mindedly. And now they're kind of trying to take these for-profit minded people and they try to kind of inspire the change agent in them. And I'm like, how did I get in here? It's like pretty tough to get into the program, 23 of us. I've been doing this my whole life. And then I was also thinking like, well, the professor from Booth was saying, I cannot tell my students today to be creative and to design your own path. This is why I'm teaching you this now, like design your own kind of like screenplay. Don't just take the path that everybody thinks you should be taking. And I was immediately thinking back to my days at Ball State. I'm like, no, this is just wrong. You need to tell your students, because otherwise how would they know, right? Like society puts you in this box and they put you on a very narrow track. So really my reason for being here and why I got so excited about this presentation is like, students, you guys are a lever, you guys are a capacitor, and be courageous, design your own path. And I actually do believe that architecture is maybe the queen, king, whatever discipline, whatever you want to call it. So we don't work in one narrow layer, we work perpendicular to all these other layers that we have to be knowledgeable about and then tie into like our projects. May it be architecture, let it be computer games, whatever, like the design theory is everywhere. So essentially with this base education, you can almost do anything. And this is a time of great challenge, especially in the environmental sector and political and global. So we have a whole bunch of challenges in front of us. 10 years ago, I was probably much more anxious about it, but now I actually really see great potential. So with this architecture kind of toolkit in your back pocket, you can really, really make a difference, and this is what I want to encourage you to do. So just a little prologue, hence the title Architecture of Change, and that's of course meant like design your own stage, design your own business, don't be afraid, like you can be a social impact entrepreneur if you want to. So keep that in mind as you go through your studies. And that's kind of like what I did. So Ball State, yes, Pam was right, Marv Rosenman, back in the day, took us to New York City, my first trip to New York, and it was the very first conference that was kind of putting on sustainability. And I had no idea at the time, I was just like along for the ride, right? Like, but after like many years, it started to make sense. Most recently, I was like looking up who went with me on that trip, and there was one very special person, Gina Bokra. She had become the sustainability director of the New York City Building Department. A very powerful position. I'm like, oh, of course, Gina, you were with me on this trip, and we went to this like conference. And then she dug deeper, and she found the list of all the people who showed up for this conference. She's like, oh my God, did you look at this? Like all the who is anything in the environmental field right now, were at that conference, and Marvin kicked us off. So really, back in the day, Ball State was maybe the first one who really like jumped in both feet ahead on the environmentally challenged issues. And well, my colleagues were complimented when they went to like whatever East Coast schools, and they're like, oh wow, you're going to Ball State? Like this is like, you guys are so ahead of everybody else. So anyway, that got me started. I put the things back together a little bit later. But so my first architectural career, of course, after I had to try to make it in New York, which I didn't, this is okay, and not everybody has to make it in New York. I came back to Chicago and I started working for Helmut Jahn. And so same thing, at that point in time I was already infected with the whole environmental stuff. And what you're seeing up here is actually a really cool project that I was working on at the time. That was one of the very first double wall facade systems, where they tried to maximize energy efficiency in the built environment. Like a lot of architects were experimenting with it, especially in Germany, they built a whole bunch of them. Of course, if you look at this, lots of glass, lots of moving pieces, and the double wall, like so you basically have an exterior layer of glass, interior. What happens is in between space, does it get dirty? There are all kinds of problems with it, and of course they stopped. It was very expensive. But So this is where I started. And got a little burnt out, and then decided to start my own business with my husband at the time. So that's what led us to passive building. It's like, well, this is all great, like all steel glass buildings and architects, blah, blah, but really they're not doing enough, and our climate change challenges are only getting bigger by the minute. We have to do something. So basically at that point, I flipped the switch and I said, like, I will not touch any other building that is not built to an energy efficiency standard that meets our carbon reductions globally that we have to achieve. Period. Like, I was going to be part of the solution and no longer part of the problem. So we went and studied first in Germany what they had done over there, and yes, correct. But Pam, I would give most of the credit to the US and to the Canadians. And with it, Bob Koester, he is one of the early pioneers, and Ceres, of course, here at Ball State. And all these pieces also in my head only packed, kind of like came back together once I understood the entire arc of the environmental building technology development that ensued as a consequence of the oil embargo, really, in the 70s. So very, very cool history. I encourage you to look into that. It's totally cool. Anyway, so my husband and I designed this first passive house in the US. It's a little dark, but it really, really shines during winter months, of course. It's super, super insulated. This was still the German standard. We learned our lessons along the way that in the US we have many different standards, and one size does not fit at all. And then that set off kind of like basically my career path of revisiting yet again passive building standards and design guidelines to make them appropriate and working in all climate zones. So this is what I just want to take you through here a little bit. I'm already talking way too long. We're definitely not making it through all the slides, but that's okay. So just let the slides kind of like sink in a little bit. What I'm trying to tell you here is really what we've learned over the last couple of years as we have gone through basically developing design guidelines for architects so that you can actually do these buildings and design these buildings essentially yourself, right? Like we developed the software. Now you're totally empowered as an architect. If you wanted to, you could learn all this stuff and you provide all the services. You're doing the energy calculations, you're doing the building science, and like, here you go, Mr. Client, like, here's your passive house, right? So that's what we set out to do. And then, so as a community now, we've been at this since 2002, and I just came from Providence, Rhode Island, where we had our technically annual conference. So where we've landed now, it almost feels like the passive building design is like training wheels. We can take them off now, right? We understood, we internalized building science, passive building design principles, how a building is actually impacted by exterior climate and interior climate, and how that essentially then informs what our wall assembly, our insulation levels, and all that good stuff have to look like. And so my second point, zero carbon standard of the future, Pam was alluding to it. Now we're coming full circle after we were like all like totally focused on this energy piece for like the last 15 years. And now we're kind of like finally breaking ourselves back out of that box. Like, okay, so really the secret sauce of passive building is like looking for all these synergies between the different systems, optimizing everything, making it the most efficient, the most resilient, the most comfortable, everything, cost effective. Now we can go back to really what was the initial driver, and that was carbon neutrality. Trying to get to some level of a balance point in the consumption of carbon, and that is the big challenge of our generation as far as I'm concerned. So back to carbon neutrality, and I'll show you how we put that on top of our design standards and principles, and then a few success stories, a couple pretty pictures. Probably by that time we're out of time, we can just click through them and just like enjoy them. And then a call to action. All right. Oh, yeah, and you probably were wondering what that damn funnel is doing there. So my entire kind of career throughout academia, like everything was always graphed as a linear process, and I really like to I want to push the BS button on that one. Really, over the last 30 years, what I've learned is like it's more like a funnel, right? Like you start on the bottom, and you're like, oh my God, this is like there's so much to learn, and like every time you circle around, you have another light bulb go off, and that's actually really, really empowering. So this is my model of learning and how I have come around and along. So 0 is the goal, Phius is the means. By now we're not even talking about passive house necessarily anymore on our website. Really the goal is to get to 0 and ideally absolute 0. And that means we have to decarbonize the grid, we have to decarbonize the operations of the building, and we have to decarbonize the embodied carbon in the materials that we're using. And all of that has to be optimized together so that we get the best result. Because there's also a very inconvenient truth, and that is, while the building sector has the best potential to make a big difference, so you're really at the forefront of solving this problem, 40% of the building sector is using most of the carbon. It is also a giant challenge, because we've been asleep at the wheel. People haven't really taken enough action yet, even though we've had the technologies for a very long time and we knew what the challenges were. But the inconvenient truth is like it is only going to be as good if we get to every single building, and that includes all the existing buildings. So that's a fun challenge. So imagine every single building being wrapped in a layer of insulation and double, triple pane glazing. That's a whole bunch of embodied carbon, right? And if we do that, tick-tock, until what, like 2040 or 2050, all of the buildings at once, we're really nicely kicking the planet in the butt with like a high dose of carbon. So it is actually becoming even more important that we solve this retrofit puzzle. So anybody who's into retrofit, that is where it's at. All right, so what does Phius do? We certify consultants, including we have the university CPHC training that some of you might be taking right now. We have been fortunate enough, we have hired 2 of Ball State's graduates who took the training, and they are now full-fledged part of the Phius team, Al Mitchell and Zoe Rader. They were both with us in Providence, Rhode Island this beginning of the week. We certify products, so if you do this, like you start your own business, like you can easily find now windows and they're recommended to you by climate zone. Who knows, maybe you have an uncle in Florida and they want to build one down there, right? So you need to find the right components for that. META is our brand new modeling tool. It used to be Woofy Passive, but now this thing has also grown up over the last 20 years. We're going into the cloud. It's going to be cloud-based, and they're working on integrating all the newest and best technologies and also the parametric design, so to further optimize our optimization. Because our optimization is a starting point. You can, of course, if you have huge computing power, you can make it even better, right? So computer modeling tool, very important. We have our building certification programs all the way to 0. We do research with the Renewable Energy Laboratory, with Building Science Corporation, Department of Energy, all the other labs actually, and then also there's our Phius Alliance. Our stakeholders are really, we're nonprofits, so who owns Phius? It's our stakeholders. That's our raison d'etre, and we are listening very closely to what our stakeholders have to say, what they want, what they need, and we do our best to facilitate that and to create new tools, and again, to make it as easy as possible for you guys to deliver these buildings safely. So passive building design actually is really quite magical. So once you put all these pieces together, what we call passive building principles, you get like all these beautiful benefits. It's a comfortable home, you have long-term affordability because the utility costs are very low. Durability is incredible because now with your brilliant building science head on, right, you make sure that there's absolutely no moisture that is getting into the wall and that can cause deterioration. Everything is built to a much higher standard. The interior health is incredible because the air is always filtered. Safety, so makes the building much safer. There's less structural failure. We think about fire, like all these things, they come first, and then everything else follows. So the building is actually really, really safe. And then the most important part is resilience. So a friend of mine has a house in Tampa. And I'm sitting in class with him at U Chicago right now, and first hurricane missed him, and he's like, oh, great, I'm going home, my family, all good. Like 2 weeks later, another one. Well, this time his house is underwater. So resilience is super, super important. And again, I'm mentioning this because you guys are on the front lines of solving that problem. In his particular case, it doesn't help that like the house, if the house had been passively survivable, that's more like when it gets very hot or cold and like your systems fail or the grid goes down. But in his case, if he had designed and built his house with flooding in mind, he probably would have not built it out of wood or fluffy insulation or drywall with like nice mold substrate on it, right? Once a building gets wet and there's like, I don't know, 2-3 feet of water in there, it's a nightmare to resurrect buildings. So we have to keep these things in mind as we design. So the secret sauce of Phius, it's maybe a little too tacky, whatever, but this is really the simplest we can boil it down. The secret sauce of passive buildings is that, well, by making the envelope super, super good, what you're doing actually is you're crushing the load in a building. And if you're crushing the load in a building, so when I say load, this is like the hottest and the coldest time of the year. If you're living in a tent and you're trying to stay comfortable in a tent in negative 40 degrees, there's not much thermal resistance in the tent, obviously, and you will have like essentially almost like you're heating the outdoors if you put a heater in there. So once we improve the envelope, we're crushing this load almost to nothing, and then we're taking passive solar into account, all internal gains. So if you do it all right, then for heating and cooling, there's a very low load left compared to regular buildings, and that is really, really key. Now, if you do this with every single building in a state or in a country, then your grid can actually shrink. Now, in our case, it will not happen because we're up against the race to electrify everything, and guess what everybody's doing? They stick heat pumps into buildings and they buy electric cars, and they don't think where this like additional energy consumption in terms of electrons, where are these electrons going to come from? The scaling up is going way too fast. If we keep doing that without really looking at energy efficiency in our buildings, guess what? We need about a grid that is 10 times as big, and we don't have the money for that. It's just like, we don't even have to start talking. We need to find different solutions. So this is really the cool thing here. If we really crush all of our loads, we can feasibly scale up what we need in terms of electrons through renewable energies, and that's what we want to do. We want to crush the CO2 emissions and the cost. I will not talk in detail about these principles. Happy to kind of distribute this presentation later. Those of you who are taking, I'm assuming this is like a requirement, right? Like systems classes, you're familiar with continuous installation, no thermal bridges, airtight construction, heat recovery ventilation, solar gain, managing summer and winter, and picking the appropriate glazing package for your climate. Now a little bit to the certification framework, and I'm sorry I'm hitting you with this, but this is really kind of important because if you just like employ these bubbles that I just showed you, right? Like you just like, okay, I'm doing this by gut. Like I feel like, okay, awesome, tons of like insulation, and this window looks good, but you don't have anything that kind of gives you a limit on the different kind of combinations for your particular climate, then you can totally overdo it or underdo it, or worse, you can do something that makes it even like worse than you had good intentions, but it didn't work out. So It's very important to differentiate between those principles. These are essentially like your strategies that you can pick from, or your tool set, but then you also need like hard and fast lines that tell you how much insulation do I layer on and where do I stop. And this is what these targets are for. And to do this correctly, you need essentially 3 kind of like frameworks that limit you. One are the space conditioning targets, and by that I mean heating and cooling, total consumption per year. And then the peak for heating and cooling, because that determines how big your mechanical system has to be to keep your building comfortable. And then you want on-site quality assurance so that like they are not like, I don't know, anybody here who has built buildings before? Probably, maybe all of you were on the alley house, and I'm not telling you anything new, but so very often a standard construction, you finish your airtight layer, everything's beautiful, right? Your building checks out like a champ, and then a trade comes in that had no idea and just starts cutting holes and drills holes and whatever. And you as the architect, you're about having a heart attack because, of course, airtightness is very important. So we have developed on-site quality assurance and testing and inspection procedures so that that does not happen. So again, back to like getting all this done safely. Okay, so design guide, some of you might have seen this. So you can go on our website and download that. And then we have targets, like limits where you design to. You don't have to totally understand this right now, just understand there are numeric limitations that tell you how much insulation you put into your building, and that makes it then comfortable and resilient. So space conditioning, it's important to understand here that the size of your building matters. This is really the only thing that you need to take away right now. If you design a tiny little building, it acts very different than like when you have a high-rise or like a big multifamily building. And the reason here is because the single-family project, let's say, you have 3 people in there. Relatively speaking, that is not a lot of internal heat that these people are generating and contributing to your energy balance. But if you have a really densely populated, like let's even say like you have like a dormitory, like everybody has their own little mini fridge and like everybody has their own little slice, all of a sudden you have a building that is like packed with all these internal gains that could be utilized to help heating the building or cooling. Very different what size the building is and the occupant density, these all make a difference in where this sweet spot is, where you set your insulation levels. And this is good news because like the bigger the buildings, my favorite right now are the high rises. The bigger the buildings, the less insulation you need, and essentially you can already get to very close to passive building standards with big buildings almost at code level. Super easy. Well, I'm saying it's not easy, but it is easier. So heating loads, again, a sweet spot based on type and size, and then we have targets for every different climate zone. And this like funny diagram that I showed you where we squish down the loads, these load profiles look different for every climate, so it's pretty cool. Again, too much science, like you don't have to understand, just like keep those like snapshots. In some climates it's much easier, in some climates like heating dominates, in some climates cooling dominates, and then from the specific climate data then these like different load profiles, they result as you try to squish it down. Over the years we also have realized that for the very tiny buildings, small buildings, they don't have a lot of budget for energy modeling. And like the single family home builders, they wandered off. They're like, oh, this is too expensive. So we came up with like a prescriptive calculator, and this is a fun thing. So back to your own company that you're going to start soon here. Go to our website. There's a cool little calculator. You can pick your climate. You can pick the size of your single family home, and it will basically spit out what you need to put into your envelope. So very cool, nice little shortcut if you don't want to get into like all the details of the modeling. So for airtightness, in the good old days, like the first round of folks in the 70s and 80s and 90s, they kind of did this. Like, oh yeah, this sounds about right. We know, like, if the building leaks air, then there's going to be moisture that gets into the wall, and then we have mold. So we have to make it really, really tight. But to give people, like, an idea, we just say, like, well, let's say 5 air changes per hour at 50 Pascal. And then we make things a little better, we double it, and so on and so forth. So that's how they initially set it. Now we went back in, and we actually looked at, like, what is the best level of air tightness, and it has something to do with your structure. Are you building your building out of something that can fall apart, like wood, that is affected by water, steel? If there's moisture that gets to it at the cold surface, it could rust. So these are all things we want to avoid, right? Like, so this air tightness criterion to build the building is as tight so that it floats in the ocean, one of my friends said. The reason for that is, like, of course, you don't want to leak energy, but more importantly, you don't want any moist air from the inside to travel into the wall and destroy your envelope. And then quality assurance. So we partner with the Zero Energy Ready Home program of the Department of Energy, with the Energy Star Indoor Air Plus program, with ResNet, and all those programs together, they have really good guidelines for quality assurance, and we have incorporated those all into our certification process. And the cool thing there is, because, like, these are prerequisites, you automatically qualify for incentives. So very, very cool. Too many numbers, but this is really just like a little, like, reminder. When you design a building in a super insulated building that is very tall, from, like, floor to the ceiling, it is very important that you have the right glass in there, that it is insulative enough in a cold climate so that there is no cold draft developing in front of it. You might have experienced this, like in crappy buildings. In the winter, you sit in front of a window, and, like, the surface is really cold, and then convection develops, and it's not comfortable. So to pick the perfect glazing, we've developed a little calculator. We're kind of geeks, yeah. Al Mitchell all ahead, top geek. And then this is our window database here with the bubbles. You can pick, like, a window, and then it will tell you which climate it is good for. We have a prescriptive guideline for how to design your wall assembly. Have you gotten into hygrothermal design yet? Yeah, okay. So when I was in school, that thing gave me a headache. I'm like, oh my God, this sounds really important, and I don't want any water on my wall, I don't want any mold. But I found the principles that are behind it very difficult, especially as you start trying to move them through different climates, right? But in general, you can make up some pretty standard rules, prescriptive rules that keep you out of trouble. We put this into this Appendix B in our guidebook, but in general, you can also just, like, clarify it by, like, looking at the roles in the wall. And Joe Stiebrich from Building Science Corporation has done that in a very exemplary manner. There's the cladding on the outside, and then the meat of the wall is really, like, you can how do you say? So you categorize them by layers, by the control layer. So there's a thermal control layer, there's a water control layer, there's an air control layer, and then there's the structure. So if you think of it as again as a layer cake, and you understand what the roles of these different layers are, you're good. So, and this is my favorite topic, thermal bridging. So if you're a real geek and you get into, like, therm calculations, and especially for retrofit construction, you probably will have to do this more than if you do it for new construction, because new construction is simple, right? In new construction, you just basically take the prescriptive requirements for the wall assembly, and you design your building to be thermal bridge free. Hello. Now you don't have to calculate them. That's what you should be doing. But in retrofit scenarios, you can't. Like, an existing building has thermal bridges everywhere, and the way you will deal with them, you will have to calculate them to put them into the energy model correctly. All right, so all that building science stuff and design and the system, how to design it and model it, now we're getting to Phius as baseline on the path to zero. So now we have designed and optimized our envelope for the building, and then to do so, we give you certification processes. So you're not alone, like you can send us your drawings and we're gonna look over everything you did, because like chances are if you do it for the first time, you're probably not doing it correctly. So certification is always a good idea. We're basically like your super team members who help you through it all the way to final certification. And these certification processes exist for all the different building typologies, for housing, for commercial, for new construction, for retrofit. And we have the baseline. If you don't have the money yet to put all the renewables on it to get all the way to zero right away, or you can go to zero right away, and then that certification we call Phius Zero. And you guys are Phius Zero, right?
Phius Zero, yeah.
Yes, you got the Phius Zero plaque. Congratulations. Certification process, jumping over that one. And the idea, obviously, so that last little criterion here in our calculations, we tell you how much source energy your total building is allowed to use. So that's actually really quite important, because only if you know that level of what it is still using, once you are done with all your optimization, then you can actually calculate how many photovoltaics you need, or windmills to take it all the way to zero, to carbon neutrality. This is probably not that important to you unless you really do it, but we do have rules in our certification process to take the building all the way to be electrified. Right now you can still use gas, and in the big buildings people choose that still, but if they do, we ask them to have a fuel switching plan for the future. And some of you might have heard of the Zero Code brought forward by Architecture 2030. They just use like the ASHRAE 189 as kind of like baseline for efficiency. We say, hey, no, not good enough, like you have to go further. So in our opinion, this should really be Phius Core, because we specifically optimized this to be the sweet spot between conservation and generation. And then yes, we agree to get to zero. You add your renewables, and that can be on-site, but it can also be off-site. So you can buy solar renewable energy credits also to zero out your remaining operational carbon. All right, now we're getting to the pictures. Yay! So initially, this whole thing in 2002 to 2010 got off the ground with various single-family projects. And I started single-handedly, like we built the Smith House in 2002, finished in 2003, and somehow people heard about this. We built a couple more as a community housing development organization. Actually, Phius was first a community housing development organization. Also not unrelated to Ball State, because there was a lot of activity around that, the Housing Futures Institute back when, and we were on site a lot, checking out affordable construction. So I was like, well, this seems like a great idea, like buildings that don't use any energy for people who don't have a lot of money. Hey, like let's do that. That's how we started, and then people found us and they said like, hey, this is cool, can you teach us? Like, now what? So I put together a curriculum and then started jetting around, like from east to west, and stopped over in the middle again, and then everything again, and started teaching builders and energy consultants and engineers and architects on how to do this kind of stuff. So from those first classes came the next kind of like generation of single-family homes. Very cool, like lots of people were really fired up. Yes, we're gonna do this, we can do this. And they started building like these individual little like passive houses in their neighborhoods in Oregon and in California and in New York. And once they had the buildings on the ground, people were able to walk in and they could actually really feel how different these buildings were. And that spawned little like interest groups. And then those little interest groups, they kept growing, and then they wanted more training. And so it was a very simple business plan, actually. So I'm kind of like a serial entrepreneur, I guess. So basically just this one house in the middle, right? Like, and then from this one house, you promulgate, and then like, then you have 4, and then each of those 4 houses, they split into 3 more, and like, if you play that game like long enough, the page is full with a whole bunch of tiny little houses. So that's essentially exactly how it worked out. And so the most recent projects, initially they were all very boxy and people were very shy trying something new. But I think we finally have figured it out how to find a new kind of like aesthetic language. And that was always like kind of like, if I had not gotten into this whole like basically trying to train in the science and writing design guides so that everybody else can do this, my dream job would have been working on the aesthetics, on the next look of like how can we embody this shift in like life quality, what we want to see in our built environment. And I feel like these projects are now really starting to look quite nice, and they are starting to express this new kind of like living in balance with the environment and care. This one project right here, I'd like to point out, some of you might have seen it in the news, I don't know if you pay attention. That is a retrofit in Austin, Texas, and they didn't have to leave their house when the what do they call this? The snow apocalypse or something, right? So even in Texas now, like they see temperatures that people are just not prepared for. And these guys had absolutely no problem. And they got into the news multiple times after that. So in Boston, this is our latest, and really quite, I still can't, I have to pinch myself, like, is this really true? And this is why we were in Providence. We should have been in Boston, but Boston has gotten so expensive. I don't know if anybody here is familiar with the Boston market. They started kicking into gear and developing new projects at like super fast rate. And so very early on, there was a multifamily project built by one of our stakeholders in South Boston. And they finished it, they measured it, and then voila, people were actually able to see how the building performed. And they were like, huh, let's compare this to LEED and to code. And they were like, wow, this is amazing, right? And then they went ahead and said like, well, but what about cost? Like, we're sure this costs a ton more money, right? We're like, no, we cost optimize those targets, right? And then they're like, okay, fine, we believe you. There was the political will there, and they said we pick 8 projects, and we give them a whole bunch of money. They build to your standards, and then in return, they give us all the construction data and all the cost data. And they did this, and voila, proof of concept. Out of those 8, like on average, like there was one outlier with 4.3% additional cost, but the rest was like kind of like averaging out between like 2 or 3. And totally understandable when you have a new team. You will have to think differently about how you do things, but so there's a learning curve. And if a team does a project for the first time, probably will cost a little bit more. But the ones that are vertically integrated, they figure out like how to get the radar and the verifier integrated, and the CPHC, the certified consultant, they're all part of the same company, and they start cranking these things out, and like almost no additional cost. And at that point, the developers said like, we can't afford not to do it. And especially the affordable housing developers. And I'm like, yes, this is where we started, right? Like buildings that are healthy and don't cost much to heat, people who don't have a lot of money at their disposal, perfect match. So now they are just rocking it out there. They're building like one affordable project after another, and they wrote it into code, believe it or not. Totally crazy. So same thing is happening in New York City and New York State. This is one of our high-rise projects. And if you look at the R values here, it's really not that bad, right? You have a bigger envelope, so the R values and the window requirements, they're a little bit better than code. So really it comes down to like the quality of install, no thermal bridging, air tightness measures, all that good stuff. And it starts to get really fun. So in a single family home, like a little ventilator, you can kind of like picture this, right? But what if you have like a 26-story high rise? Like now what do you do with the ventilation? And the ventilation is not what you know from regular buildings. You have like, you need, this is like low flow ventilation. So it's a little bit of a technical feat. And then this project, again, it's affordable, beautiful like apartments, immigration background in that neighborhood. It's in the Bronx, 12 minutes from LaGuardia, if you're ever there. Like, remember, for 25 Grand Concourse, very cool project. They had a local artist, like make art and put it up in the common spaces. This is the NYSOTA team. I was very happy to finally be there, and a common roof terrace, like with like Manhattan in the background. It's just ridiculous. Cab driver was like, "Wow, what are you doing here?" I'm like, "Well, I'm visiting this. This is an affordable building." He's like, "Can I be in this building?" I'm like, "Yeah, you should research this. This is not super expensive. Well, for New York, still probably up there, but." Anyway, so the success story is stretch code, local law 97, basically passive. Opt-in stretch in Mass, now all multifamily buildings have to be built to the Phius standards in Massachusetts that are larger than 12,000 square feet. We're expecting about 200 large-scale multifamily projects out of Mass for certification. And then because we didn't trust that, belt and suspenders, we also decided to turn our design guideline into an ASHRAE standard that then doesn't even need us. Then the building inspector can just require, like, you're going to do ASHRAE 227P, and then basically people have to do passive building standards. Lots of incentives out there, also for retrofits. This is one of the most recent ones completed in Boston. It's a CLT project. Yep. And then even sleepy Chicago, like they're always a little behind. They watch the East and the West Coast and they're like, huh, what are these people doing over there? Finally finished their first multifamily affordable one within the city limits. Yay! And it only takes one. And then way back when, for all commercial buildings, for those of you who enter commercial buildings, Rocky Mountain Institute, Amory Lovins, one of my heroes, physicist, at the beginning of all this movement of environmental construction and building technology. In 2015, he finished his new Basalt headquarters for the Rocky Mountain Institute. And that was right when we had reconfigured our climate-specific standards. And I was like, Amory, can we try our standards on your building? And he had like 70 experts, like economists and physicists and whatever, to come up with a sweet spot for his envelope. And we ran it through our model. Bingo. It was a perfect fit. We're like, yes. So we got the guideline, and we got the guidebook for that. Lots of... in academia, lots of people are now building the residence halls to our standards, a whole bunch in Princeton, Harvard, all over the place in the Northeast. And this is one of my favorite projects, most recent in Chicago, the Academy for Global Citizenship. This is a positive energy building designed to teach basically kids from like kindergarten up how to, like, they have permaculture gardens. This is a zero water, everything, like the whole thing. And it is also a Phius Zero project. I'm going to skip over this one, though. You might want to look into this. This is really where my focus now lies with the U Chicago. You might be like, what are you doing? You're still directing Phius. I'm like, yeah, but now we can draw the boundary beyond the building. What happens if we harvest the synergies with the grid, right? Like, what if we build a microgrid and like a whole city block is now built off of Phius buildings, and we gang them all up and we overproduce, and everybody is as efficient as they can be, and we sell back to the grid, and we give people fractal. I'm missing the word now. Fractional ownership, right? So anyway, I'm going to blast through this because, like, first efficiency first, that means you need less insulation, less renewables. And then the cool thing is, like, once you gang it all up and you tap into these microgrid and direct current additional city block synergies, then it's totally awesome, right? Like, so actually your output multiplies beyond just the linear addition of efficiency plus PV. And that's really the secret sauce. And some of you might have heard of the duck curve in California. They raced all ahead, like Californians wanted it the best, and all of a sudden they were overproducing so much energy that it became worth nothing because there was nobody there who could use it. So then they're like, oh, we need all the storage, and then, well, it has a lot of issues with storage. But and we do need storage, but we need a whole lot less if we first do energy efficiency in buildings, and that's when we can flatten out the stock curve, because again, we crushed the loads, right? Like it's all going back to the loads. And this is the cool story. With passive buildings and load flexibility, we're reaching our goals, and there are incredible savings to be had. And then others are taking note. They're basically saying efficient grid responsive buildings would make a zero carbon grid 100 billion cheaper per year. The numbers of like how these synergies like ripple are incredible. So that's the next frontier that I want to crack. There's already one 6-unit building kind of like microgrid on the ground in Maryland. But they haven't gone to all the way where I would like to take it, like bigger scale. Lisa White, our newly minted co-director, wrote a architect's guide for ultra-low energy buildings, microgrids, and direct current. Now again, this is like totally projecting into the future, right? Like except this 6-unit house, we don't have any of this yet. So in case you start your, and I'm coming to a close, in case you're starting your own like socially impactful entrepreneurial business, which I strongly like to encourage you. So if and when you get your hands on a larger development like this, this is the J.J. Carroll redevelopment in Boston, that's perfect size. And then you optimize all of it, you gang everything together in a microgrid. You have all the appliances being direct current so that you don't have losses, because alternate current, direct current, renewable energy is direct current, right? Like, so why are we like going back and forth? And then you have one connection to the grid, and that community could then sell their overproduction to the benefit of all. This really addresses everything. It addresses our housing crisis, it addresses the cost of the housing. In my mind, it's like if developers saw this, it's like I can become an energy company from the bottom up. I have a whole bunch of these blocks. Maybe housing can become free. How about that? It's just infrastructure for people to make energy. Now we got something, right? So I encourage you to get your gears going and like come up with some ideas how you can reorganize and solve for the problems that we have in the world. And we are going to be at Greenbuild this year, which is a big deal for us. New audiences. We've been kind of like in our little like I don't know, building science bubble. Now we're talking to the entire green building world. Very exciting. And we have also committed to having our next PhiusCon in Milwaukee in 2025. All right, only 3 minutes past 1. Thank you.